Welcome back, Calc. It is the third video on integration by parts. Today we are dealing with cyclical parts. So I want you to consider the integral of e to the x cosine x. You probably just watched the video on tabular method and you're probably thinking, oh, let's try tabular method. Except for the fact that which one has a finite number of derivatives, e to the x or cosine x? And the answer is none. So we have to go back to the good old-fashioned parts formula and set it up that way. So we're going to find our u and we're going to find our dv. Okay. Now, technically, doesn't matter. You can pick whichever one you want. I'm going to pick my u as e to the x and my dv as cosine x. That makes my du e to the x and my v sine x. So when we set it up, I now have uv minus the integral of v du. I'm just going to put the e to the x in front. And you're thinking to yourself, holy moly, we have to go again. So we go u. I'm going to stick with my e to the x just because it's what I picked in the first go round. So du is still e to the x, and v in this case is now the negative of cosine x. So keeping this part the same, e to the x sine x minus, okay, this is our big old bracket, so to speak, and we have uv, so the negative of e to the x cosine x minus the integral of v. I'm going to pull that negative out and turn that into a plus. So the inside is e to the x cosine x dx. Right there. Okay? So, distributing my negative through into my bracket, I'm going to go to the next page here, but that's going to give me e to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x. And this is when you're probably saying, oh my gosh, this is never ending. And I'm going to say, wait a second, what are we trying to solve for? What does this right here, what is this whole thing that we've just done so far, what does it actually equal? And you're going to go back to the original problem and you're like, oh, well, we're equaling the integral of e to the x cosine x dx. Now, I understand this would be a lot nicer if it was all written in one line for you to see, but I write too big, the screen's only so large, and so lo siento. So, anyways, what I want you to notice here is what's equaling each other. Okay, so this is what we were solving for. This was the initial problem right here, the integral of e to the x cosine x dx. We did two integration by parts, and we ended up with that underlined red function. But notice how it also contains e to the x cosine x dx. So what we're going to do is we're going to move this integral that's on the left-hand side in black over to the right-hand side of our equation that's in red. And we're going to end up with e to the x sine x plus e to the x cosine x equals the integral of e to the x cosine x, cosine x, then dx. Now, if I already had one integral and I add another one to it, I actually have two of those integrals. Algebra. Wonderful. And now what I need to do is I just want to solve for this e to the x cosine x. I'm wanting to solve for this was my original problem right here, which means I need to move the 2. How do I undo multiplying by 2? And I'm just going to divide. So I'm going to end up with the integral of e to the x cosine x dx equals, when I divide by 2, I'm just going to slap that 1/2 in front, 1/2 e to the x sine x plus a 1/2 e to the x cosine x. And am I done? No, we have to add our constant. So there's our answer right there. And you're probably thinking, holy moly, that took forever, but there's not going to be that many of these on the quiz, don't worry. And let's go again. So, numero dos, let's look at the integral of e to the 2x sine 4x dx. Okay, we got to pick our u. I tend to always just stick with the e function, the exponential that we got going on. And we have sine 4x. So that makes my du 2e to the 2x. And my v is negative 1/4 cosine 4x. Alright, setting it up. uv. I'm going to put that negative 1/4 in front. So I have negative 1/4 e to the 2x cosine 4x minus the integral of v du. Okay, so the negative 1/4 and the 2 are going to make a negative 1/2. I'm going to go ahead and pull that to the outside, making that a positive 1/2, leaving me with just the e to the 2x cosine 4x on the inside. You want to take all those constants to the outside of the integral sign, so that way your inside function is going to be similar to the original, since you know you're going to have to add it over. Alright, and now we have this stuff going on in here, and we're going to have to go again. U will still be e to the 2x. That'll give me the same du of 2e to the 2x using the chain rule. And dv is now cosine 4x, which makes v 1/4 sine 4x. Alright, and setting this up, keeping the original that I had, negative 1/4 e to the 2x cosine 4x plus 1/2, a big old bracket. Okay, uv, we have 1/4 e to the 2x sine 4x minus the integral, and again I'm going to take that 1/2 to the outside, and I'm going to jump down here because I'm going to run out of room, minus 1/2 the integral of e to the 2x sine 4x. Close that big old bracket. Alright, I'm going to jump to the next page, and we're going to distribute the 1/2 and go from there. So, negative 1/4. Let's see if I can try to fit this in all in one line. Highly doubtful. Sorry. E to the 2x cosine 4x. That's going to become a plus. The 1/2 times the 1/4 is going to give me 1/8 e to the x sine 4x. And then the 1/2 and the negative 1/2 are going to give me a negative 1/4 the integral of e to the 2x sine 4x. Of course, that's a dx. And then you're thinking, okay, this right here is what we're going to have to move to the other side, because this whole equation is technically equaling, if I had room, it would equal the integral of e to the 2x sine 4x dx. So I'm going to take my negative 1/4, the integral that's on the left-hand side, add it over to the right-hand side. So that'll leave my left-hand side being negative 1/4 e to the 2x cosine 4x plus 1/8 e to the, that should have been a 2x up there. Sorry. So e to the 2x sine 4x. And now that's going to actually equal 5/4 of the integral of e to the 2x sine 4x. And I'm running out of room, so dot, dot, dot there. All right, how do I undo multiplying by 5/4? Oh, I can multiply the other side by 4/5. So when I have 4/5 times negative 1/4, that actually becomes negative 1/5 e to the 2x cosine 4x plus, okay, multiplying by 4/5, I'm now going to have 1/10 e to the 2x sine 4x, and don't forget to add your constant. So there's our answer right there. And ladies and gentlemen, that is your cyclical parts. If you want to do some more problems to practice, because we are done with our examples, page 346, go ahead and do numbers 19 and 20. There's our good practice on cyclical parts. And we've covered all 3 methods of integration by parts. Hope you guys have a good one. Talk to you soon.